This is your Learn recording for ions, cations, and anions, Part A. Bill Nye says, I've got my eye on you. Keep your eye on the charge. And remember, ions are not the same thing as isotopes. By watching this video, a student will be able to successfully meet the following learning objectives. I can identify the number of valence electrons for main group elements. I can define and use the octet rule. I can identify cations and anions. There is your lesson summary. We will look at some of the other learning goals in the Learn Recording Ions, Cations, and Anions Part B. Be sure to watch both Part A and Part B for Lesson 7 Ions before taking the quiz, and do some practice before taking the quiz as well. There are some practice problems, or there are some calculations you'll have to do on the quiz in terms of ion charge, so it's good to do some practice problems before the quiz. When we are thinking about ions or neutral atoms, anything related to charge, whether the atom is neutral or it's an ion is an atom that is not neutral, an atom that has a charge. We are interested in two subatomic particles. We're interested in the protons and electrons. When we talked about isotopes, we were interested in the protons and neutrons. When we talk about ions, we're interested in protons and electrons. We're going to ignore the neutrons when it comes to ions, cations, and anions. The word atom is referring to an atom with no charge, an atom that is neutral, an atom in a situation where the number of protons equals the number of electrons. So the word atom tells us the number of protons is equal to the number of electrons. We cannot call an atom that has a charge an atom. We use a new word, and that word is called ion. So we do want to make sure we're distinguishing and using the right term. Atom and ion are not interchangeable. I tried to make a play on words just to make a point there, but the word atom is only used when it's neutral and the protons are equal to electrons. When you have protons and electrons not equal, we are going to call that an ion. We won't call it an atom, we will call it an ion. IONS. That's an ion. The protons and electrons are not equal. And there we have that. Just to reiterate again, if the protons and electrons are not equal, we call it not an atom, but an ion. Anything that's an ion is charged. Anything that's an ion is charged. It has a charge. We do need some background content to move forward in the lesson, ions. And one of those pieces of background information that we need is the element types and their location on the periodic table. We need to be able to identify metal elements, non-metal elements, and metalloids on the periodic table. They will have certain properties that will give them certain number of valence electrons and will allow us to predict what type of ions they form. So we will want to be able to identify where the metals are, where the nonmetals are, where the metalloids are, or if given an element, be able to say whether it's a metal or nonmetal. And one easy way you can look something up is go to your web browser and type in ptable.com or just ptable. It will bring up a link or a list, and at the top of the list, you'll have the dynamic periodic table. That's a nice periodic table to use for this class. So there are trends on the periodic table we will see as they relate to valence electrons and ions. But the trends that we need to know start with metals and nonmetals. We need to know the term valence shell and valence electron. They are going to be part of our understanding of ions and whether an atom will form a positive or negative ion, whether it will gain or lose electrons. Valence shell. A valence electron shell is the electron shell that's farthest on the outside of the atom and that contains electrons. The valence electrons are electrons in the valence shell. So here we have marked in red the electron shell that's farthest from the nucleus and that contains electrons. The electrons in that shell are valence electrons. So that's the valence electron that lithium has. Sodium has one valence electron as well because there's one electron in the valence shell. The valence shell is the third shell from the nucleus. I'm on the outside. That's what the valence electrons are saying. They get to interact with the outside world. They get to participate in chemical reactions. And that's why we're interested in the valence electrons. And there's a nice view of two valence electrons on the outermost energy level or the outside electron shell. We're interested in the valence electrons. They will be the ones that participate in chemical reactions and bonding. So we will focus on valence electrons for the most part here on out. There is a link in the slide set that you can use to access another site that gives you some interactive exercises with valence electrons and something we call a dot diagram, something we do with those valence electrons that helps us visualize them in another way. We will look at that another day, but if you want to go ahead and try that out, just open the slide set. The valence electrons have a pattern that we can see on this visual. It will be a pattern we want to know or be able to find on a reference table or sheet or screenshot. Valence electrons match the group number that the element is in, but it does depend on the format of the periodic table you're looking at. There are two formats for periodic tables. If you're looking at the type of periodic table that is AB, where you have group 1, 1A, group 2, 2A, we're going to skip over the sunken block in the center. We're not going to look at those elements in terms of ion formation in this class. And then we move over and you have 3A to 8A. If you have a periodic table that has that format style, the number of valence electrons matches the group number. The number of valence electrons is 1 for 1A, 2 for 2A, 3 for 3A, 4 for 4A, 5 for 5A, 6 for 6A, 7 for 7A, and 8 for 8A. If you're looking at a periodic table that has a numbering system 1 through 18, 1, 2, then we skip over that center block that's sunken in the middle. That's called a D block. And then it's 13, 14, 15, 16, 17, and 18. Here is what you do. You just need to take the last digit to get your valence number. So for 13, you just use the 3. For 14, you just use the 4. For 17, you just use the 7. Otherwise, it's pretty easy to find the valence electron count just by the group number. Valence electrons, they are why the elements in the same group have similar properties, because all of the elements in group 1 have one valence electron. That's why they have similar properties, because they have the same valence electron number. All right, we have to know what this thing called the octet rule is, because it's going to guide us in terms of ion formation. The octet rule is, I want 8 valence electrons in my valence shell. That's what the octet rule is. I want 8 valence electrons in my outside shell. The noble gases are happy and satisfied because they have 8 valence electrons in their outside shell. All other atoms want to be like the noble gases. They want to have 8 valence electrons in their outside shell. They're going to try to find a way to deal with the situation if they do not have 8 valence electrons in their outside shell. Because if they do not have an octet, they're not satisfied, they're not happy, they're not stable. So here we have some atoms and examples of how they feel. Lithium has 1 valence electron in its outside shell. It does not have an octet, so it's very unhappy. It's very reactive. It's mad. It's angry. Oxygen has 6 valence electrons in its outside shell. It does not have 8, so it's feeling pretty frustrated. It doesn't know what to do. It needs to do something. Fluorine has 7. It's very, very, very desperate for one more. Here's what the atoms can do in terms of trying to deal with their situation if they do not have an octet. They can either try to find a way to gain electrons and get to 8, or they can try to find a way to get rid of their valence electrons and go down to 0, be empty. So they're going to do one or the other. They're going to try to gain and get to 8, or they're going to try to get rid of their valence and go down to 0. So these are the two options we're going to see in terms of ion formation. And we're going to see that certain types of elements do one and another type of element does the other. Oxygen has 6 valence electrons. Oxygen has 6. Well, with 6 valence electrons, what are the choices? In order to get to 8, it would gain 2 to get to 8 valence, that octet, so that's one choice. But it could also go down to 0. That would be losing 6 valence. Well, what's oxygen going to do? Well, if we think about every electron costing $100, either way, whether you're gaining or losing, this is $600, and this is $200. We can see that oxygen is going to gain 2 electrons. It's going to gain 2 electrons to get to a full octet. So oxygen will, in order to get to a full octet, find an atom that will donate electrons and gain 2 electrons in order to get to 8, and then it will have a full octet in that outer shell. When it gains 2 electrons, how does that alter the charge? What kind of charge do electrons have? Well, it's gaining negative particles. So when oxygen gains 2 electrons, it gains 2 negative charges. So it moves from neutral to a negative ion. It becomes 2 negative. It becomes a negative ion with a 2 negative charge because it gained 2 electrons. For every electron an atom gains, it gains 1 negative charge. So oxygen is happy with a 2 negative charge because that gives it a full octet. That's how ion formation works. That's how ion formation works. So let's look at an example for a metal. The lithium atom, let me go back there. I went one slide too far. There we go. Apologize. There we go. The lithium atom has 3 protons, 3 electrons. So with 3 protons and 3 electrons, it's neutral overall. But if we look at the electron shell or Bohr diagram, Bohr model of lithium, we can see that it has 1 valence electron in the outside shell. So here are questions or steps we can go through to determine what this atom will do to deal with the situation. Here are the questions we look at, or the steps we look at. A, how many valence electrons? That's the first thing we determine, 1. Then B says if there are 8 valence, we stop, we're done. Well, that's not the case here. C says if there are less than 4, the atom will lose the valence electrons. So that's the situation here. So this is telling us that lithium is not going to gain 7 electrons. That would cost $700. It's going to lose 1 electron. That's only going to cost $100. So lithium, in order to become somewhat stable and happy, lithium is going to lose this electron. And when it loses that electron, it will get rid of that valence shell. When it does that, it will have 2 protons. Or excuse me, I apologize. I meant to put that down by the electrons. It will have 3 protons and 2 electrons. And so what will the new charge be? Well, we can figure that out. We can figure that out. We can see that here, if we look at the chargeometer, for every positive and negative pair, they cancel. That leaves us with 1 positive charge left over. We can also use the formula charge equals number of protons minus number of electrons. There are 3 protons minus 2 electrons. So charge equals +1. So we have for our answer a lithium +1 ion. That's the solution for the metal lithium in group 1. Now let's just add some vocab for positive and negative ions. There are some special names that we have for positive and negative ions. If we have an ion with a positive charge, we call it a cation. So if we have an ion with a positive charge, we call it a cation. Cations are ions with positive charges. Metal elements are going to form cations. Kat the cation has a gold necklace on because she loves metal. She has plus signs for her eyes because she forms positive ions. And she does this by losing electrons. And here are just some other cute ways to remember cations are positive. Cats are happy. They have paws, so they're positively positive. Cations have more protons than electrons. That's why they're positive. If we're talking about a negative ion, it's called an anion. So for example, our oxygen 2-, our oxygen ion with a 2- charge, that's an anion. Nonmetals form anions. Nonmetals form anions. They do that by gaining electrons. So Annie, the anion, eats electrons. She eats electrons, and those are electrons in her belly. Because nonmetals gain electrons to form a negative anion. And here are just some ways to help us remember anions. Anion, that word is close to the word onion in terms of spelling. And onions, when we cut them up, they make us cry. So that's a bad thing. That's a negative thing. Negative anions are negative. If you look at an iron, which is kind of similar to anion, the slots at the bottom of the iron look like negative signs. Anions are negative. And that's going to wrap it up for part A. After watching this video, a student can now successfully meet the following learning objectives. You can identify the number of valence electrons. For main group elements, you can define and use the octet rule. You can identify cations and anions. Have a great day.